Semiopen impellers can be used for pumping thin liquids, since there is a shroud to direct the liquid between the vanes. They can also be used for heavier liquids and slurries, since they minimize clogging. Impellers can also be classified in other ways. For example, closed impellers can be further classified as single suction impellers or double suction impellers. This impeller is a single suction impeller. It has only one suction eye, so there's only one place that the liquid can enter the impeller. Single suction impellers are fine in applications where the pressure change across the pump is relatively low. In applications where the pressure change is higher, large amounts of axial thrust are created and must be offset. To minimize the effects of the axial thrust, some centrifugal pumps use a double suction impeller. A double suction impeller has two suction eyes, so liquid can enter the impeller from opposite directions. Because of this, the pressure on both sides of the impeller is the same, and axial thrust is minimized. No matter what type of impeller a centrifugal pump uses, the liquid being pumped gains pressure as it slows down to fill out the increasing volume of the volute. Radial thrust is a type of thrust that tends to move a pump shaft perpendicular to its axis. In a pump with a volute, the thrust is created by the difference in pressure across the volute. Now, some centrifugal pumps are equipped with a component that accomplishes the same speed-to-pressure conversion as a volute, but minimizes radial thrust. It's called a diffuser. A diffuser consists of a series of stationary vanes that surround the impeller. When we look at the vanes closely, we can see that the distance between the outer tips of the vanes is greater than the distance between the inner tips. As a result, the vanes create a series of small volutes all around the impeller. This arrangement of vanes balances the radial thrust around the impeller. Pumps require some type of seal between the pump shaft and the casing to keep process liquids in and contaminants out. Some pumps use packing to seal around the shaft. Other pumps use a device called a mechanical seal. On this cutaway of a typical mechanical seal, we can see the two basic parts: a stationary element that's attached to the pump casing and a rotating element that's attached to the pump shaft. Each element has its own seal ring. The two rings are positioned close together to form a seal that has virtually no leak-off. To prevent the seal rings from being damaged, some type of lubricant must be supplied to them. In some applications, the process liquid being pumped is used as the lubricant, but that's not always the case. When the liquid being pumped could be hazardous if the seal fails, or if it contains abrasives or other solids, such as in a slurry, an external liquid may be used to lubricate the seal rings. Many facilities use an independent system to provide lubricating liquid to the mechanical seals of several pumps. This is a simplified diagram of a typical sealing system. It provides lubricating liquid to the mechanical seals on all of the pumps in a process. The system consists of a storage tank, a filter, a supply pump and a backup supply pump, a low-pressure switch, a pressure regulator for each mechanical seal, and a flow meter for each mechanical seal. For this process, an oil is used to lubricate the mechanical seals. During operation, the supply pump draws the oil from the storage tank through the filter. The filter removes contaminants from the oil to prevent damage to the sealing system pumps and the mechanical seals being supplied. The pump supplies the oil to the pressure regulators on each supply line. The pressure regulators control oil pressure and the amount of oil flow to each of the mechanical seals. The flow meters allow the flow to the seals to be monitored. If the supply pump fails to deliver the oil at the correct pressure, the pressure switch will sense this condition and automatically start the backup supply pump to restore pressure. At the mechanical seal, the oil lubricates the seal rings. The oil then passes by the seal, flows into the return header, and is sent back to the storage tank. From there, the oil can be reused. In this topic, we looked at some of the different components that make up centrifugal pumps. This included different types of impellers as well as a diffuser. We also looked at the components and operation of a system that provided lubricating oil to mechanical seals. Now let's try some practice questions. A diffuser consists of a series of stationary vanes that surround the impeller. When we look at the vanes closely, we can see that the distance between the outer tips of the vanes is greater than the distance between the inner tips. As a result, the vanes create a series of small volutes all around the impeller. This arrangement of vanes balances the radial thrust around the impeller. At the mechanical seal, the oil lubricates the seal rings. The oil then passes by the seal, flows into the return header, and is sent back to the storage tank.